Me llamo José Ignacio y lo que os voy a...
Good morning, my name is José Antonio and I will be sharing with you the design of a platform for cybersecurity scenarios. We aimed at learning and training. Well, this is me. I am an IT engineer and my participation in the world of cybersecurity has been through CTFs, competition, challenges, etc. I have taken part in the two European cybersecurity challenges in 2016 and 2017. The first one was held in Düsseldorf and the second one here in 2017 in Malaga. And actually, we were the winners. So we had a great time, okay? And then now CTF, Cyber Camp, which will be held this Saturday. I participated in all the editions and I won the one in 2015 and I was second in the 2017. So therefore I am very much used to take part in competitions, in hacking and CTFs, etc. And well, this is related to the platform that I will be sharing with you. This is me, this is a company where I work. SGS is a Swiss company, it's a multinational company. It's present in 165 countries and it employs some 100,000 people. Why a platform of these characteristics? Well, previous speaker told us that in Spain, or well, all over the world, the attitudes of people working in the field of security is extremely important, and then the aptitude and the attitude has to be focused on in learning, in training. In cybersecurity you have to get training and learn, and that training requires having a number of resources. So this is not about studying only, this is not theory. So everyone, electricians, plumbers, very many professions have to put things into practice, have to practice, and we have to practice at a cybersecurity world. So that's what I have set up the platform, offering simulation and platforms or scenarios similar to those that we will be facing in the real life. And here we have two elements: scalability and final costs. Well, perhaps for companies, cost is not a significant problem, but in the world of education, cost is a crucial factor. And this is what I try to optimize in my platform. And I believe that cybersecurity training is based on 3 pillars. Nowadays, there are very many, nowadays and in this sector, there are many self-taught people. There are very many competitions that help us learn a lot. And also we have university training. University training is getting better and better in this new field, in this quite new field, and then universities are adapting to real world, but still we have a small gap between university and real life. And then we also have professional certifications. And I believe that these are the 3 pillars when it comes to cybersecurity training. So now, there are other challenges, platforms out there where people learn on by doing. I very much like Hack the Box platform. I'm sure many of you have tried it out, have did several challenges. I'm quite hooked to it. To me, this is a significant source of learning. Very interesting. Okay, so what is the focus of Hack the Box? Well, it has a base with thousands of users, and these users are updating content all the time. So there is a new machine every single week at 5 p.m. every Saturday. New content is included or offered. So these are virtual machines. Well, it has a number of implications that we will refer to later on, but to summarize, there is a high cost of infrastructure if we wanted to replicate this model at a university. So now, which is the business model of Hack the Box? This is based on a subscription. So you have the option of not paying anything and to share a scenario of machines with very many other users. Sometimes sharing some of those machines is an actual problem, it's a big problem. Your training capability is quite reduced. However, you may go subscribe to it, and then you share that lab, that scenario with 20 people. The problem with this type of a scenario is that the advancements and progression of people you are sharing the platform with may either benefit you or be a bit, detrimental for you. But anyway, it's a model. It's a model which I feel is good, and the problem of it is the high cost of it if you want to implement it yourself. And then also another downside, this is not an open platform. So motivation for me to work in the platform. I was doing the dissertation at the end of my master's course, and then I decided to focus on this topic for my dissertation. So the challenge is platforms that are open source do not manage the infrastructure of the challenges, that is to say the virtualization. These platforms only manage these core points, how to insert the flags, but they do not manage the challenge infrastructure. And then there are also other off-the-shelf platforms. I will not say out any names. I've tried some of them, and actually I've used some of them in competitions, for instance here at INCIBE, but they leave a lot to be desired. They are not that good. So therefore I decided to improve whatever is available out there. And I said, well, is this a business opportunity? Well, I decided to go for it, and I'm quite happy with the outcome. So this is the work that was presented at the GNIC 2018, and we got a diploma. So it's an award to the best article about training and innovation. So now let us move on into the platform and its design. Well, the technical architecture, technology used is quite simple. It's based on Linux. The front end is Angular GTS. It's Angular JS. So I have thought about rewriting it in a different technology, Google or other, but that will be in the future. And now I want to shift it into something which can be compiled. But the prototype that we use is Node.js and AngularJS, and the performance so far so good. So in terms of virtualization and lowering costs, the main proposal is using Docker containers. This implies many things. So this should be based on Linux. It is lightweight and it is scalable. And as it is designed, it can be configured in Swarm module or cluster module. It is plain and simple, so the platform allows you to set up many parallel servers. When we say many, we refer to 4 or 5. Remember that the objective here is to lower costs, and it is an API REST controlling the infrastructure, very easy to implement at university. For instance, with authentication at university, features and everything. And then it proposes a standard design of scenarios, so everyone knows how to do Docker. Any students who want to produce a dissertation can provide content to this platform. So, well, there are also some shortages. Only few platforms can be virtualized, but well, we are not talking about virtualizing here. Well, perhaps Linux and Windows 2016. You may introduce applications.NET Core, but not very many possibilities. Alternatives are also proposed to support other platforms. The main problem is the kernel is shared. Any kernel vulnerability makes your platform vulnerable, and you cannot propose it as a scenario because it doesn't give you the necessary protection or isolation. But here we find an offset in between how hard it is for you to make it and what you can do. For instance, because if a student is doing something which should not be doing, okay, well, you can also get to know about it. So it is quite an acceptable trade-off. Okay, you know what people are doing with it. It is like copying in an exam. Okay. And now, well, we will be discussing IoT later on because this is an interesting proposition. IoT devices can be used through a shift system. Often we have 5 devices from the same model, and the students or candidates or those who are getting training have to share these devices. And then also hack the box model. So what it is known as boot root, and it is a virtual machine with a snap shell, and then you configure the challenge and you may reset it as many times as possible. You reset it over and over, and then you set up 5 or 6 in parallel for each scenario. But as well, that means that the cost will grow exponentially. But if needed, the platform would also support it. And then we have infrastructure as a service. Why having local virtualization when you can start the machines when the students or whoever is getting training needs them? So if you need 100 machines for 3 minutes or 40 minutes, then you will be invoiced only for those 40 minutes, and then the platform will be integrated with the IaaS platform, whether it is Amazon or you name it. Okay, so this is the idea. It is not fully finished, but it is quite simple to implement. Logical architecture. Well, but it is important, first of all, to have the logic of the competition, and then on the other hand, the logic to manage the infrastructure, which is the main driver for this project. So recent improvements, things that are yet to be tested. I tested them in Lausanne, Switzerland, the past weekend, and if they allow me, I would like to implement it at the Polytechnic University in Madrid. Support for virtual machine, infrastructure as a service, controlling costs. Well, we will see whether we will succeed in that. Then a couple of keys have been generated for the equipment. Everything is unified. Well, 2 keys would allow you to access all the scenarios, all the challenges. Also, it automatically manages the VPN access if needed. For instance, a network at the Polytechnical University in Madrid, Wi-Fi is available to students. So not all the ports or entry or inbound or outbound ports are open. So how do we resolve that? We resolve that through VPN. VPN allows us to control all the activity that is carried out on the platform. We can produce analytics, we can produce or retrieve interesting data. So, well, this has been integrated in the platform. It's up and running and works very well. And then supports for physical devices and IoT hardware, side channeling, etc. And the management of the different shifts. Now let us look at the scenarios that are supported by the platform, especially the Docker model. And we start off with the most simple environment, okay? So containers is started, the user logs on against that container. So to design the challenge this time, the only requirement is that the Docker container, but you may have whatever you want to have in it, but it should have entry node in the 1337 port. And then the user will have to log on to this URL and to this port, a random port. And every time you start the scenario, the port changes. And then, well, different ports for different equipment. So this provides isolation between isolates the different devices, but all the members of the team can access to the same scenario, to the same container, so that they can work in parallel or on the same container. So this is what we was very much desired, and then we achieved it. This is very simple. You can do that in 10 minutes. You don't need a platform to manage that for you. But what is actually interesting is this, this more complex setup. I hope you can read it. So you have an entry point in the scenario, and then the scenario has several networks with several containers in this case. So you go into SSH container or through the web, and then you pivot from there, and then you escalate privileges in that machine. Then you move on to the other user, you get more information from the other user, you move on to, you may access to the second network, but only through the container. The user cannot access that network through the device, has to go mandatorily through this intermediary node. And then there are other services and other visible containers that let you to access more networks. And how to design these exercises? Well, in theory, this is quite simple. You have, first of all, to define the networks that you have, the networks to which each container is logged in, and then an entry point. And the entry point has to go through 1337 port, which simplifies content management. And now the complexity and, well, at the end of the day, cost, okay, which is what is driving this project. So all this depends on the complexity of this scenario, because we are talking about containers. Is quite, can be easily scaled. So at the end of the day, you will have students grouped in 3 or 4 teams. So at the end of the day, training professionals, working individually, well, that's a different story that we are not talking about now. So to summarize, at the end of the day, you will have less than 80 teams, less than 80 instances in this scenario. And probably this scenario, in the best case, at the end of the day, we will be having like 8 containers. So it is cheap. It is cheap in terms of resources, in terms of machines. So an example, 10 scenarios such as this one on the screen with 40 people, 18 team, consumed or used up 1 gigabyte of RAM with 2 CPUs that were virtualized, CPUs from Amazon. Basically, it went very well, performed very well. Users did not complain at all. 12 euros for 24 hours. Affordable. Now examples of exercises that can be supported by this platform. I will be sharing 3 categories: cryptography, exploiting, web analysis, 3 different types of scenarios. And the most simple example is statement, a headline. You enter the solution and that's it. Any open source platform can do that for you. This is a cryptographic puzzle. This is the statement, and then this is the solution. So you have a base 64 chain. You code it, and then you have a hex chain. And then the secret message is this one. This is the flag. Then you insert it here, and that's it. Okay, so no mystery behind it. Now, a more complex exercise would be an exploiting challenge. You have a binary, but you don't have to download it in your computer and trust it. No, you don't have to do that. The platform gives you an environment. Well, in this case, a container. You launch the container, and then you get all login details. Some host, port, username, password. This is an SSH chain. So you first configure the private and public key, and the actual platform gives you the command that you need. So you do cut and paste, and then you just go through, you log in through that SSH. And then it tells you you have binary in -app, gives you the tool that you need to debug the binary, to do overflow, whatever you want to do. So this one, we will resolve it later on in our demo. This one and the next one, which are simple. Success cases. Where have I applied this platform? And I give you the most recent example. I applied it in an event last weekend in, Lausanne, in Lausanne, Switzerland. It was the Polytechnic University in Lausanne, Switzerland. 19 challenges, including 17 IoT challenges. So I will show you a few photographs. 17 teams, 40 participants. The consumption of hardware resources, 2 CPUs and 1 gigabyte of RAM. So invoice worth less than 15 euros, 24 hours. So that was the objective. And the user experience was very flowing. And what I've seen in the last 5 years in competitions is at the end of the day in virtualized environments, the user experience is not never too good. Because, everything is slow, you are just, you typing in one language and then you get like a Cyrillic language, so not a good user experience, but not last weekend. So IoT. So the problem with IoT, often you have your own network for each device or pairs of devices. Do you know what you can see? Okay, top left is light bulb. Then this is an IP camera. On the right we have radio frequency. So we take a hack RF, and then they had to communicate or broadcast walkie-talkie communication. So this was an NFC reader for control access, presence sensor, and then we have this electronic lock, then temperature control, temperature sensor, driving fan, and then the presence detector activated an alarm. This was resolved doing the man-in-the-middle attack. We had a Wi-Fi network for all these devices here at the bottom, and basically this works through HTTPS. So you apply RP spoofing, and then you hijack the connections, and you can do whatever you want to do with the sensors, actuators. So the objective of the challenges were these ones. These were basic challenges. They were not advanced challenges. So this was quite a basic training for students at this university. They were not cybersecurity professionals, although I should say that some professionals joined in, and then, they did all that in 2 to 3 hours, and the students took 24 hours to resolve the challenge. In the case of the camera, it was very simple. API, LAN mode control, you sent in commands, and then IP camera is vulnerable to a well-known exploit. Rather than an exploit, it's a backdoor. You send in a command or a request, HTTPS, which is poorly run. You connecting get login .cge with no dash intro, and what you get back, username equals this, password equals the password that you gave to it. And then you go into the camera as an admin, then you see the Wi-Fi password, and then taking advantage that there are like some 100,000 cameras connected to the internet. So you have access to some 100,000 Wi-Fi all over the world, but that's a different topic. So these are IoT challenges. We gave students half an hour for each device, however, that can be multiplexed. So if a team was working on the light bulb and another one on the camera and another team was working on the button devices, the button devices cannot be multiplexed because they had to do a net spoofing and you don't really want to multiplex it because you cannot do it. Okay, you cannot work in parallel. So what do we get from the platform? Does the platform deliver? Well, it allows you to manage shifts. So let us say a team gets an appointment from 3 to 2:30 for this challenge, from 5 to 2:30 for this other challenge, from 6 to 6:30 to this other challenge. And for this challenge, you have to read this document. For this other challenge, you have to read this other document. Well, which is a good way to start. So these are students resolving the challenge and the winners. And now, well, let us see whether the platform works, and we can see a live demo. Okay, that will be brief. So there are two panels here, a user panel and admin panel, and we are primarily interested in the user panel. I am already logged in. So there is a profile. It tells you where you are for each category, where your team is, where you are in your team, and then you may download the VPN config file, which is the solution used for VPN. In this case, it's not needed. May be needed. Then you just log on to the public URL. For this web app, you don't need VPN, but from here you may download the file, then you import the VPN PIN or PIN, and then you may access challenges right away. And this is the team, public team. Well, actually, there are a couple of keys, and then you download the private key. I don't know whether you can see it here, bottom left. It is very simple. So this is the panel for the challenges. We started off with the easiest one. Well, resolving this challenge was very easy. So this is a string, and you say base 64 for sure. Then you code it. Once you put it into practice, well, the students found it difficult to resolve this one, and the next one was much easier. Well, I found it very strange. But the thing is that because they couldn't read, I don't know whether you can read it or not. This is an hexadecimal chain. And, well, they found it very strange, and they did not continue. If they were to read, this is the secret message, and this is the hexadecimal chain. If they had done that, they would have resolved it very quickly. So it took them an average of an hour to resolve this challenge, which is quite strange. Okay, 25 points. Okay. So this is the scoreboard that we used last weekend. So this is scoring. This is a horizontal line standing for a week. We see the, what each of the teams did, how the progression, and it's quite user-friendly platform. And now when you need a virtual environment, let us go to the first exploiting, which is easy to resolve. You click on it, very quickly it gives you the environment. You copy the command, or you just type it in. But you can copy it. Then gets logged in. I don't know how to enlarge the screen so that you can follow it. So you see binary there. There are many ways to resolve it. Well, GDB is one of them. And then it uploads a front end on GDB. That is to say, it gives you the tools that you need. It also has Radare and other tools. You don't really need to download the binary or having anything installed in your computer. So I'll show you how the binary works. So you run it and then it says, okay, give me a password. Then you enter the password and then it says, no, that is not the right password. Then we debug it very quickly. Then we give it an argument. We see the log, the stack, the disassembling we are doing step by step. Okay, this is basic thing to do in exploiting. Well, actually, you cannot consider this an exploiting. Then here, right on top, we see part of password. Okay, we have the logs, the stack, and it is comparing that to all the contents that have entered. Okay, give me a sec. Okay, we should be getting it now. Here it is. This is the password. Okay, password is just a random password. Okay, and then it gives me the flag. Important, this is a dynamic flag. If I pass it on to another team, it will not work for them. So flag is generated every time I launch a scenario. So this is good because it helps people not to cheat. Another an easier way to resolve this challenge, because this is a string in the binary. You do a grep flag or grep password, and then you get the password. It is faster. This was just an example for you to see how the platform manages that. You may buy a hint, and then you use the string command, and well, you resolve the challenge very quickly. Well, there are other challenges that are more complicated.
Because this other thing helped you contain access to a container through SSH, and it says connect to this VRL, and I know is STP and not STDS. There's the container, just for you in this case. You solve it, it's a filter, the database, a table. And you have a flag. It's easy to solve, etc. It's a web panel, dashboard. You push the button, you have the URL, you click, and you have the environment to solve it. So it's trivial. It works correctly because the environment is only active if you're solving it. If you're not solving it, the environment is not consuming resources. And once you solve it, the platform throws this away. The user does not have to do it, and if it's open for more than 1 hour, it's also thrown away. So it's configured so that after 1 hour, it's thrown away so that it does not consume resources. The administration panel, which is in Spanish here, you can see active environments. In this case, there's nothing. But you can more or less check what's consuming resources, the flags that have been captured, when, who in the team. You see this an active environment here by demo device. It shows the state. You can access the environment and you can check the logs of that container. The platform has an event record. The events that I think are interesting I've recorded. It takes the time to load because there are recordings for 24 hours. Basically, demo device has logged in at this time. This challenge has been solved. The clue was bought. The hint was bought, and these are the types of events. We're a bit behind schedule. I'm going to solve a couple of other challenges so that you can see the spirit of the competition, for those of you who are not familiar with it. This one is interesting. Only one team solved it last weekend. It's an exploiting environment, but it doesn't give you the binary code, no SSH. It says you have to connect through a socket to this and the binary response. How do you face this? You connect. It gives you a user, hola. Give me a password, hola. It says no. Incorrect credentials. I'm open a text editor so you can see this more easily. With this little script, we solve the challenge. So basically, for exploiting challenges, there's a framework in Python which is quite useful. Pawn tools. I strongly recommend it. Just listen to their 2 points. You send string format, which is vulnerability, and it basically iterates to download a block of the process memory, which is what you're doing here. The flag is transmitted as an environment variable, or the comparison is in the memory. The password against which you're comparing to the memory, it's going to be shown in that piece of memory you've downloaded. So for each position, I connect, I send the command I want, and it returns 8 bytes memory, which is interesting. So I'll show the vulnerability here. Percentage P, memory pointer. First, I'm going to give 1, which is the first position. This is the first position in the memory in hexadecimal. So I do the same thing. Two, and it gives me the next piece of memory, so to speak. So I execute this solver in the port given by the platform. It starts to dump the memory until it finds the flag. takes a while, a few seconds. Well, step by step, there's not much left, I think. And there you find the flag. It finds the flag, so it's swapped. Simple challenges with very basic notions. We've seen a series of environments. There are more. This one, for example. It was solved with just one team. It's a handbook buffer overload. You don't have the binary to debug it. Sorry. And no one tells you have to go to this direction within the binary code. SLR is activated. Perhaps it's not that easy. This would be the solver in this case with pump tools. It's easy to do. The only difficult thing is finding the offset. It was a small buffer. If you iterated the offset in which you control the red, in this case was 38. The direction is given by the binary code itself. You code it as you should, and then you get the flag in this case. We execute it to see how it is. I don't know if you can see it, but this is the flag, quite simple. If you ask for a hint, use binary, a function called scanf, which is vulnerable to overflow attacks. Another example, because I haven't shown any complex scenario, a nice example was this one. If you connect to a container through SSH, the environment says there's a container in another network. If you put DNS challenge, it's going to enroute you. There's a Docker problem, which is that you cannot control IPs, you cannot use fixed IP, so you need to use the internal DNS in Docker, which is the name of the container, more or less, and it's enroutable. So the environment is called challenge. It's going to enroute you, but you have no idea what the IP is. So every time you launch it, it's a different IP, and it's very complicated to use fixed IPs. It doesn't make sense in this case, but you work with an internal DNS, and that's it. That's what the platform does. It has disadvantages too. In this case, the machine is responding. Write this to say something. And in this case, you connect to a server. It says access denied. This is your token. This was a great idea. If you realize that there are weird numbers and consecutive numbers, the name is Autenticación Alternativa in Spanish. It's authenticating based on your source port. I can't remember the name of the parameter. I think it was this one. I can't remember the name. Local port. I can't remember. This one. If you send the HTTP request with a specific port, which is 31337. You realize that it was authenticating against your local port. You're given the flag, and that's it. To measure lateral out-of-the-box thinking of candidates. This platform, beside training and education, it's designed also to hire staff. I'm a company, I have a red team, a pen testing team. How do I know that candidates that are arriving have the knowledge or not? But they have the exercise, but they do it themselves, the girlfriend, their team at the company. I need them to know this, to have the skills. I can have specific exercises with a specific topic, and as a company, as a team leader, I can assess their skills and whether they comply with the requirements I have for a specific profile, or perhaps it's more generic, more dynamic profile, what I want. I can measure this with it. So could you please go back to presentation? These are my conclusions. The cost of visualization strategy is pivotal, more particularly for teaching environments, which was the main goal of this project. Well, it was that. Any question?
¿Ninguna pregunta?
No questions? Well, that's it. Thank you very much.